In this case, we've been asked to find the values, a and b. Well, values mean these are constants, such that g of x is continuous and differentiable. So for us to be continuous, then the left side of the equation, sine of x minus a, must equal x minus b cosine of x. If that weren't the case, we could have something with a jump discontinuity. We need to force these 2 points toward each other. And so the only way we can do that is if the y's match. So I will plug in my pi over 2 because that's where we want our function to be continuous. So now here's where we need to have some good understanding of our unit circle. Sine of pi over 2 is 1 minus a must be equal to pi over 2 minus b cosine of pi over 2. But cosine of pi over 2 is 0, so this whole term can be erased. Adding a and subtracting pi over 2 from both sides gives us a equals 1 minus pi over 2. But this equation gave us no information about b. I still don't know what that is. But that's okay. For something to be differentiable, it must be continuous and equal slopes. And only when I consider equal slopes will I have f prime at pi over 2 minus equaling f prime at pi over 2 plus. So I'll take the derivative of the left side, that's the minus side, and I'll get the derivative of sine is cosine of x, and the derivative of a is 0 because remember, that's a constant. It's just some number we're solving for. We actually found what it was. 1 minus pi over 2 is just a number, and its slope is 0. The next side of the equation, the derivative of x is 1. The derivative of b cosine theta will be minus b sine x. Well, these two negatives become a positive, so I'll just erase them and make a plus. Again, I can now substitute in for pi over 2. On the left we have 0 minus 0 equals 1 plus b times 1 because sine of pi over 2 is 1. Well, that means b equals negative 1. Now I've found both constants.